Guys, in this video we're going to talk about how to use the Plysmlt app to solve a system of equations such as you might find in complex circuits. So to begin with, probably you all know how to get to Plysmlt already, but in case you don't, apps button, and then you can scroll down to it, or the easy way, the quick way if you've got like 50 apps, is you hit alpha and then P, and it takes you straight to it, if you had to page through like say 50 apps to get there. All right, now we open it up. And here we are in the Plysmlt app. Now, probably what you're most familiar with is the polynomial root finder, which is great if you're trying to do things like find the roots of a quadratic or a third-order polynomial or whatever it may be. But we're going to use the simultaneous equation solver part of it. I guess I got to hit the down button. There we go. All right. In simultaneous equation solver, you can select any number of equations. So it'll solve a system of 10 equations if you want. All right, fine, great. And let's see, we want the number of unknowns we're trying to solve for in our particular case is going to be 3. But again, it could be 4 equations and 4 unknowns or whatever. As you can see, I already have the equations up over here. These are the ones that we came up with in the previous video. If you want to know where those came from, then you should go watch that video. But we're just going to use 3 of them to solve for the 3 unknowns. And one of those equations I'm actually going to discard. All right, everything else looks probably okay. You could choose decimals or fractions. It doesn't necessarily matter which one you want to go with. How about I'll go ahead and select decimals just for fun. Normal, float, and then degree or radian's not really going to matter. All right, so then we're going to go to next, second, next. There we go. Okay, now this right here is the system matrix. Now, it might look a little bit different on your calculator, but the appearance is different, but the format is identical. What this is doing is solving a matrix, right? Now, if you haven't done matrices, that's okay. What it's basically looking for is variable number 1 goes in this column, variable number 2 goes in this column, variable number 3 goes in this column, and if the equation has equals something other than 0, that goes over here. So what you have to do with these equations over here is rewrite them in the order that we are expecting for our system matrix. What I mean by that is as follows. It's got to go in the order I1, I2, I3. That way we'll be able to consistently plug things into our matrix in sort of an order that we can follow much more easily. And then any constants go over here on the right side. So rewriting the first equation, we would get this. Now, what have we done there exactly? All I really did was I moved I2 over to the other side of the equation and then wrote them in order I1, I2, I3. Okay? Now, when we plug that into our matrix over here, the things that go in on this side are the coefficients for each term. So that first term, the coefficient is a 1. Okay, so I guess I have to type 1. And then next spot, enter. All right, the next one, the coefficient is -1. And the next coefficient is just 1. Now, you can probably guess that when we get to these equations over here, it's going to be a little more interesting because we won't be just typing 1, -1 and stuff. It'll be like 10 or 8 or -10, okay? All right, so the other side of the equation over here is, of course, 0. We can leave the 0 as is because that's what the equation is set equal to. And so now we can proceed to the next equation and reformat that and type in the coefficients we need. So what I would like you to do is pause me, rewrite it yourself, and see if you can predict the equation I'm going to write and the coefficients I'm going to plug in. All right, here we go. Our second equation, or at least that's one way that we could have written it. Obviously, I don't need the 0 I3. That term's in there really mostly just to keep everything visually organized, right? All my i's in the same column, okay, I2 in the same column, I3. But of course, it's just a placeholder. I don't technically have to write it. The other thing, of course, is you may have done it in such a way that, well, I got -10 and -8 and -12. Is that okay? That's identical. There's no difference. So sure, you may do it that way. But whatever, I find this is probably the best way to put it. All right, let's type that into the calculator. Wonderful. We've typed that one in successfully. And then now we just need to do our third equation in our matrix. Well, wait, hold on, Mr. Erico. There were 4 equations here, and I just realized we only have space for 3 equations. Well, that's because back when I was in the sort of main menu, I said 3 unknowns, 3 equations. We don't actually need all 4 of the equations we came up with. So really, I could just go ahead and get rid of this one right here if I don't actually want to use it. Okay, so fine. We're just going to use this one and turn that one into another equation. But sure, right? We could, if we wanted to, include a 4th equation, but it's not necessary. And I would say extra work for no good reason. All right, so let's turn that one into the format we need. And there's our equation. All we need to do now is put that into the matrix and then hit solve. And amazingly, we will have all of our values. One thing I want to show you real quick before I hit solve, and that's that on this last one, people often don't actually enter it. See, I have it typed down here. It's ready to be entered, and if I were to hit solve right now, what would actually happen is it would solve the matrix as though there were a 0 there. So please remember, you got to hit enter before it actually records it. All right, now let's hit solve. And those are our solutions. So this is current number 1 as labeled in our original diagram in the previous video. There's current number 2, there's current number 3. We've got them all. Now, last thing I want to mention, this app is super sensitive to changes. Meaning, if we were to go back to the system of equations, if I made a sign goof, like say I made this 6 over here, -6 instead, we would get totally different solutions, okay? So if you're not getting the right answers, the first thing to check would be that you entered all of your signs correctly. If you don't have any mistakes in entry, well, then it may be that one of your loops is wrong, and then you got to go back and check, again, signs on your loops. If you've checked all of that, well, that's actually where one of the mistakes is probably one of your loops is wrong. The other possibility, to start, that we only needed 3 equations. And so you might have thought, well, I can pick any 3 equations and it's going to work. Well, actually, at least one of your equations must be a junction. If you don't use any junction equations, you actually can't get the right answers. So of these equations here, if I picked, let's say, just the loops, turns out that if I were to take, let's say, equation number 1, and subtract equation number 2 from it, I get this 3rd equation. In other words, the 3rd equation is actually an identity of the first 2. So really, actually, I have to make sure that I use at least 1 junction equation if I hope to get the right answers. All right, so we'll hit the solve button just one more time. Boom, look at those beautiful, practically effortless answers. All right, hope that was informative. Thanks, guys.